This is Gail Kovac for Gresham Barlow School District, Summer School, High School Credit Recovery, Geometry, and Learning Target number 8. I can find angle measures created by parallel lines and a transversal. So in this first example, we've got parallel lines. Those are lines that continue in the same direction forever, such that they will never cross. And when they are intersected by a third line that goes across both of them, then they make some interesting angle measures. So in fact, here with our markings, you see the double marking here, that says that this line here will continue forever in the same direction as this one down here, and they shall never cross. Those two lines are parallel. Then we have transversal is something that goes across, trans meaning like traveling across. So this one goes across the two here, and it makes a total of 8 different angle measures. We've got the 84 degrees and then 3 other angles at the top, and then 4 other angles at the bottom. So essentially, this is kind of like doubling something. We've got our first top line there in red that gets cut by the black transversal. And all 4 of those angle measures actually get copied and pasted down below in that exact same one here. So this angle measure given to us is 84. That one corresponds to this one down here. This one's also going to be 84, and that's just a copy paste situation. You bring this one down here and it'll land perfectly on top of that one. So those are called corresponding angles. Now, we've also got some, let's say, alternate interior angles. So these are interior angles, meaning they're inside the parallel lines, and they alternate across the transversal. So these two that I've marked in blue are on opposite sides of the transversal, but inside the parallel lines. And interior alternate interior angles are congruent. So this one is also going to be 84 degrees. In fact, we could know that because these are vertical angles across here, vertical angles, right? So then this one at the top here, that one's also going to be 84 degrees because it's vertical to that original 84. These are corresponding angle to that blue 84 degrees I found below. So we've got opposite vertical angles, 84, 84, 84, and 84. Now, how do we figure out the other ones? Well, consecutive interior angles, so these are angles that are on the same side of the transversal, but on the inside of the parallel lines, that's consecutive interior, those two have to add up to 180 degrees. Like this 84 and this purple angle here, they're a linear pair. They make up a straight line, so they have to add up to 180 degrees. So if I figure out 180 minus 84, I'm just going to double, triple check my calculations here. Yes, this needs to be 96 degrees right here. So if this one's 96, then alternate interior angles, this one here has to be 96 as well. In fact, these two make a linear pair here. That's got to add up to 96. These are consecutive interiors on the left. They got to add up to 180. And then we've got some vertical angles going on here. Again, we've got 96 across here. Sorry, that 6 doesn't look amazing. And we've got 96 across here. So all you need is one angle and you can figure out all the other 7. In fact, it's pretty easy. It's just a copy paste. The top angles are all going to be the same as the other angles at the bottom. You've got lines hitting each other lines in the same direction, so it's going to create same angles. And once you find one, you subtract from 180 to find a linear pair, and then just vertical angle those suckers right on over, and you got all of them there sitting and waiting for you. All right, now we can use that information to in parallelograms. A parallelogram is a 4-sided figure where the sides that are across from each other are parallel. So we can use that to try and find some stranger missing angles, along with some other things we might know, like triangle sum theorem. So let's take a look here. I've got an angle in this triangle, which is 52. I can't triangle sum theorem that one because I'm missing two others. And this angle down here at 60 doesn't help me figure out what this question mark is yet because I'm missing that third angle up at V right there, WVX. So I got to figure out a few in-betweens before I can get to that question mark. And looking in a parallelogram for parallel lines is gonna work. So, YX is one side length of the parallelogram, and I've extended for visual purposes. That's going to be parallel here to WV. So I'm going to do my little arrow marks to say that those are parallel. Those are parallel. Now let's see if we can find a transversal that cuts across. In fact, I've got a transversal that cuts across at VX right here. There's your transversal. So remember some of those things that become true with the angle measures there. So here I've got an angle. This is 52 degrees. And in fact, it's going to be the same angle as, and here we are just letting you know, I'm going to kind of white these out a little bit. We're trying to ignore these lines right here, right now. We're trying to ignore those like they're not even there. So I'm going to color them white, because those are technically other transversals, but I don't even think we're going to need that here. So you just want to kind of zoom in, focus in on one of those transversals and ignore the other one. So I'm looking at the black one, VX. So in fact, that 52 degrees here, that makes an alternate interior angle with this one at the top here, angle WVX. So this is 52. This is on opposite sides of the transversal, but inside of the parallel lines. Alternate interior angles are congruent. So that one at the top there also has to be 52. Now that was super helpful because now I've got this triangle WVX that needs to sum to 180 degrees, and lo and behold, now I've got 2 out of the 3 of the measurements, and I can figure out what that question mark has to be. So let's add up how many degrees we have so far to get up to 180. We've got a 60 and we've got a 52. Let's see what that buys us so far. So 60 and 52 make 112. That's my degrees so far, but I need to get up to 180. So let's figure out how much more we've got left over. 180, subtract the 112. That gets us 68 degrees remaining. So that means that this missing angle measurement that I was looking for has to be 68 degrees. That's what will make the triangle add up to 180. So the key here is in a parallelogram, you know, opposite sides have to be parallel. You've got to try to zoom in and just focus on 2 sides that are opposite each other that are parallel, and look for a transversal that cuts across. You can try ignoring those other lines. Sometimes it gets a little complicated. It's hard to do that, but try and ignore those other lines and just look for those matching angles like alternate interior, like these ones are alternate interior. Those 2 are alternate interior. They make X's in the middle. Honestly, half the time, that's the most important one. You've also got alternate exterior here. This 96 has to match with this 96 over here, etc. They're alternate, but they're outside the parallel lines. You've got lines that add up to 180. You've got vertical angles, lots of stuff to look for, but yeah, you're looking for that structure. You're looking for 2 parallel lines and a transversal that cuts across to try and match up some angles to get what you're looking for.